Welcome to Chapter 15, How to Work with Arrays, Sets, and Maps. In this course, I've actually moved up to the more advanced section briefly for this one chapter. We'll head back to the previous chapters that we jumped over, but right now we want to get you sort of prepared for ES6 constructs. We've covered a little bit of ES6 elements in prior lectures, but arrays are so important because the data that you deal with in web development, specifically the development side of WebD, is going to deal with data. And data is often stored in arrays. And so we need to understand the difference between arrays, sets, and maps and how to display data. Almost everything we do as full stack developers has to deal with data, where we store it, how we access it, and how we display it. So think big picture. Think of web development from 30,000 feet. You're going to have a lot of sites and just all sorts of digital products where you're feeding data into that when you're on the job. And it's our job to understand how this data will come in, what type of data we're dealing with, and how to display it. So let's get started. So I love going over the objectives. It's one of the things I love about this text. And what we want to do is be able to apply arrays in our applications. We need to use associative arrays and arrays of arrays in our applications. So there's going to be arrays that have arrays inside them, and they could be nested to multiple levels. And we'll need to use sets and maps in our applications. So the applicability of this is the most important thing. Now, you should be able to describe the creation and use of an array, but that's far less important than actually dealing with one and working with it. So again, very separate from computer science where we do a lot of theory. This is really about applicability. I'll need you to describe the use of indexes and length property for working with an array, which we've already done. We did that when we jumped into constructs in chapters 2 and 3. We'll need you to distinguish between the use of for of, and for in loops for working with an array, which remember, an array is just an object. So all we have to do is figure out what loops to use and how to get all elements of an array and the ones we want specifically. You should be able to describe how destructuring can assign the elements into an array to individual constants or variables. So what that means is taking an array and cutting it up into, let's say, a usable string. And we'll get to that right away. That's actually very simple. So we're going to go over a bunch of array methods, push, pop, unshift, all this stuff you should know so that you can use it when it comes available. I will give you a cheat sheet. I use one myself when I can't remember what I need to do. So there's always Stack Overflow and some other good sites that can help us when we run into a jam. But these functions are very common, and in fact, they exist in multiple languages. So you'll need to be able to describe methods of an array. So we've talked about more methods, finding things, mapping them, sorting them, reducing them. Most of the methods described here are exactly what they say they are, but you need to see them in action. Like the word sum may not be intuitive to you, but when you see it working, then you should be in good shape. We need to describe the isArray method, which tells whether something is an array or not. We need to be able to split a string into an array. We need to copy an array. We need to distinguish between an array, an associative array, and an array of arrays. Very separate. You'll start getting into JavaScript object notation at this point. Eventually, we'll be going into this in much more detail. Many of you may decide to use JSON in your final projects for this course. You'll also need to describe how you convert an array to JSON and back and forth. So when you're working with data, it's really important that you know how to convert and what you can convert from and what you can convert to. Lastly, the array is different than a set, which is also different from a map. So we need to take a good look at the differences and how we can work with them. All right, so a lot of this will be reviewed from chapter 3 when we're first getting into the most simple constructs. We use the new keyword when we're creating an array. That's a constructor. So a constructor is any function that runs when a class runs or an object runs. So it constructs an array ready to be filled with data. Now the length itself will be an integer. So a new array of 3 would be an array that will contain 3 elements. They may not have been defined yet, but it will contain, you're cutting out a memory for 3 elements. There's also the static array of method, which we'll take a look at when we look at examples. It'll make much more sense than me describing it. And lastly, using an array literal, where you use the blocks to say, okay, this is an array. And that's the one that's, I think, most used, the shorthand, but we will get there. So the syntax for creating an array and assigning values with one statement is simply using the new keyword and putting the list inside the argument of the new array. When we use the of method, we will also do the same thing, but it's static and unchanging. Lastly, we have something called an array literal. We'll use the blocks and we'll put the list inside the blocks. All of these examples, by the way, are in this week's module folder, and once you go through the code, it should make more sense. These are examples that create an array and assign values within one statement. So I have a constant here called rates, which will never change. Again, constants never change. And it equals new array, and we have 4 different numbers. When we use the array of method, we're using integers, but we're listing all the elements of that array. And lastly, you see an array literal where we have 3 strings, Grace, Charles, and Ada. So the syntax for referring to any element of an array, you simply put the index number inside the array name inside the blocks. So if I have an array called students and it equals Charles and Ada, then if I did array name 0, 0 would be the first member and that would be Charles. So remember, arrays are 0 index. So rates 2 refers to the 3rd element in a rates array. Names 1 would be the 2nd element in a names array. Now, how to assign values to an array by accessing each element? Well, you can access these arrays, as we saw in the previous slide, by putting an index integer into blocks next to the array name. So here we have an example of constant rates that equals new array 4 elements. The 0 member has not been assigned yet, but on that second line, it does get assigned 1495. If we go back a couple of slides, we see the same numbers are in the top using the new array. In this case, we're just using the literals to assign values to each individual element of the array. In the second example, we're assigning strings to an array that starts with no elements. We're using names equals empty blocks and then adding 0, 1, and 2, Grace, Charles, and Ada. Now, a property of an array could be called length. That is a property of the array. An operator of an array or a method of an array could be a delete. These are both examples of properties and methods of the array object. Now, let's say we wanted to add an element to the end of an array. Let's say we have an array called numbers that has 3 elements, 1, 2, and 3. What we can do is use numbers.length, which is the number of elements in that array, and make it equal to a new element. Why is that? Well, because it's 0 based. If we look at the original array, numbers equals 1, 2, and 3. So the index 0 is 1, 1 is 2, and 2 is 3. So therefore, the 3rd element, or numbers.length, which is 3, would be equal to 4. 0, 1, 2, 3 is now the 4th element. So all we have to do is use numbers.length as the index, and we can assign it another value which would add to that array. We can also add an element at a specific index. Let's say we had an array of numbers that had 1, 2, and 3. So we have 3 elements, 0, 1, and 2 would be their indices. We can actually jump ahead and make numbers 5 equal to 6, which means the array would be 1, 2, 3, index 3, or the 4th element would be undefined, the 5th element would be undefined, and then the 6th element, which is index 5, remember 0 based, would be 6. We could also delete a number at a specific index simply by using the method delete. So the method delete next to numbers 1 here would delete the 2, because 0, 1, 2, the numeral 2 is the number 1 index for that array. So all we have to do is write the word delete, and we can delete a number at any specific index that we want. Lastly, we can remove all elements of an array simply by assigning the length property to 0. That clears out the array. Now this is going to be a little more confusing. This is a sparse array that contains 999 undefined elements. We have a constant number that equals 1, so that means the array contains 1. Next, we have that value that already contains 1, and we have numbers 1000. So remember, 1000 in that index would be equal to 1001. So the array now contains 1 and 1001 with 999 undefined elements in between. So the index is the 1, it's not the value. Remember that. So numbers 1000 is 1001 because that's what it's equal to. Now this is an array that's used by a loop. So let's say we have constant names Grace, Charles, and Ada, and we have names 5 equals Alan. So there will be 2 undefined elements between Ada and Alan. Again, because 3 and 4, the indexes 3 and 4, have no values. So what we can do is use a for loop with an array. And this is the syntax for processing all elements of an array. We can use our for loop. We can let our index start at 0 because it is an array. As long as the index is less than the length of that array, we can add 1 to the index on each turn of the loop. Then we can write a statement that uses the index to access the array. And lastly, we can deal with the element's value and do something with it, either output it or construct a string or something like that. And the last section here is the code that uses a for loop. So let's say we wanted to display Grace, Charles, and Ada. We would let display string equals empty because we're starting the string. We're just basically typecasting it. And then we're for looping through the length of the names array, and we're concatenating using the plus equals so that on each turn of the loop, our display string would equal each name. So we have display string on the first turn of the loop being Grace, then Charles, then Ada, then undefined, then Alan. Let's say we wanted to skip the 2 undefined outputs. We could write if names block I closing block equals undefined, or does not equal undefined, then output the variable. So you would write exclamation point equal undefined and then output it. So only names that were not equal to undefined would be output. Now this is how to use a for in loop with an array. The syntax itself is for let index const or let, because it depends if it's changing or not, but let would release the memory after the end of the construct, the loop anyway. So most of the time you're going to see let. So let whatever the number is or whatever the index of the array element is in array name, then we do something on each side. So there's an example. So let's display string equals empty. We're again declaring the variable display string to be an empty string. And for the constant I in names, we can add to the display string and use plus equals names I plus empty. And in this case, it would be Grace, Charles, Ada, and Alan. Now notice the undefined variables got overridden. They did not get displayed. So the for in loop will ignore the variables that don't have the indices that don't have value inside that array. This is how to use a for of loop within an array. So the syntax, again, let value of array name. So this for of loop is similar to the for in loop with a couple of exceptions. Note how if we use for val of names and concatenate that string, the undefined values show up now. So for of will get every value in the array regardless of whether it has a definition or not, whereas for in only displays values that are undefined. So the question might rise, when would you use a for of loop and when would you use a for in loop? Well, you would use a for of loop if you wanted to go through every single value of the loop. You would use a for in loop if you wanted to ignore elements of the array that didn't have value. So when you destructure an array, what you're doing is letting identifiers be equal to that array. Here's an example. We could have totals that equal 4 numbers, and we could have a constant full name that equals Grace M. Hopper, 3 elements. Well, look at what we do in example 1 here. we have constant total 1, total 2, total 3 equals totals. So what we're doing is assigning those variables to that array. So total 1 would be 141.95, total 2 would be 212.25. So it's almost like the array can be reversed. It can be converted backwards and forwards between literal and actual array. Now, if we look at example 2 and we want to skip an array element, we can do first name and then empty and last name equals full name Hopper. So what we get here is the Grace Hopper without the middle name because we've skipped the middle array. We're only grabbing the things that we want. This is an example 3, of using a default value. So I have first, middle, last. Remember, it was Grace M. Hopper, and suffix equals none. So think of how the data is stored here. If we have all 4 of those values and being equal to the full name variable, remember the full name variable was Grace M. Hopper on the previous slide, then the first would be Grace, the middle would be M, the last name would be Hopper, and suffix would be equal to none. It actually has a value because it was assigned a value up top. In example 4, we're using the rest operator to assign some elements to a new array. So I've got total 1, total 2, and ... the rest operator remaining totals. So what happens there? Well, the total 1 is 141.95, total 2 is 212.25. The remaining totals are the rest of them. So the ... will assign elements to that new array. Remember the totals had 4. The 4 were 141.95, 212.25, and then the third and fourth elements of the array were 411, 135.75. We can also destructure a string with an array. So if we have USA, we can have first, second, third, etc. The first is U, the second is S, and the third is A. So let me describe the nature of this because JavaScript's a little bit weird. What I'm going to do is open up Chrome real quick and go in the console. And we're going to do a quick little thing that may surprise you. Let's say I have a string. Let's say I have a constant string, and I make name equals Chris. Okay, just like that. And then I do console.log, and let's say I did name 0, just like that. See how it's a K? Even though it's a string, it acts like an array with indices. So watch, if I did console.log name in 3, I would get the 4th element of my string, which is an S. Very interesting, right? A little bit different than what you might expect. So what we're doing by destructuring this string is making first, second, and third equal to USA. Well, that string has a 0, a 1, and a 2. 0 being the first, S being the second, and A the third, and we've destructured that. So we just did some entry-level array stuff. Almost a lot of it was more review from chapter 3. But the terms I need you to know are array, element, which means specific elements of an array, the length, which is the number of elements in an array, an array literal, that's when you declare an array with the blocks, an index, which is what you put in the blocks to get that specific element of the array, a sparse array, where we spread the array, a destructuring of an array, which we did, we reversed it and assigned elements to an array, that's destructuring, and the rest operator, which is the ... which carried us out to the end of the array when we only listed a couple of things. And the rest will save you time. You'll see it referred to as a spreader later on.